Alright, so I've published a longer video that goes through the process for this, but I want to really help people who want to understand how to solve quadratics using this new method. So I'm going to make a number of videos that will take you through the process. This series of video that I'm going to do now, these two problems I'm going to do, are really just to take you through the step-by-step approach, how we apply this. If you want to see how to do more challenging problems where a might be a number apart from 1, you'll have to see my other set of video after doing this. But I wanted to make some small ones to just get you going. So this is incredible. This method is incredible because it takes away a lot of the problems that teachers and students find when they try to help students when they're working through the problem. Quadratic. So let's have a look at it, and you'll see initially it will be a bit slow, but just follow me. So normally when we get quadratics, we ask you would focus on this number and say, what numbers add up to get 15? You have to solve the problem. Say what numbers multiply to get 15, and if you add them, you get 8, yeah, or minus 8. So but we work on this in this way. Now, what I want to do is switch the problem because the Babylonians used a system over 4,000 years ago that solved quadratics, and I don't know why we don't have it in schools. And that's what this is about, to teach you this method. And I want you to show your teachers and say, this is the method I use, and see what happens. All right, so here we go. So the Babylonians switched it and said we're going to focus on the sum, meaning look at the middle number rather than at the end number. And this is against the idea that your teacher would say focus on this number, find pairs, and then see which one adds up to the middle number. Babylonian system is different, so be ready. So the big question is what two numbers add up to get 8? You'll notice that I go for positive 8 rather than minus 8. And that's just the way in which the problem is set up. So we will ignore we'll just do 8. But effectively, it's just the way that the problem works. So it's important to remember that step. So what we're going to do is do a kind of a mathematical leap here. So this is the most important step in this problem in terms of understanding the conception of the problem. So here's what we do. We want to try to find two numbers that always add up to 8. But there are so many numbers, but we can create every single number if we think of it in this way. We find an unknown number called m and take that away from both. Now, irrespective of what m is, 4 minus m and 4 plus m, if they add together, will always give you 8. Don't believe me? Let me show you. If m is equal to 2, 4 take away 2 is what? 2. And if m is still equal to 2, 4 plus 2 is 6. 6 plus 2, 8. Let's try another number. If m is equal to 4, 4 minus 4 is 0. What's 4 plus 4? 8. 8 plus 0, still 8. So we're not missing this. If m is equal to even minus 1, 4 minus minus 1 is 5. 4 plus minus 1 is 3. So it always works. So this is like any two numbers, doesn't matter what m is, will equal to 8. Now, this is fundamental because now we're trying to find the two numbers. We want to find these two numbers when multiplied together. That gives us 15 in this way. So if 4 minus m multiplied by 4 plus m equals 15, what is the m? You see, if we can locate this m, then we would have solved our problem because our problem is to find those two numbers that multiply to give us 8 and then solve the problem from that. So let's go. Multiply, add together to give you 8. So let's go. So now we know that these two must multiply to give you 15 in order to be able to solve the quadratic equation, because that's how the roots are organized in a quadratic. So we expand, difference of two squares, the middle term disappears, so 16 minus m squared is 15. Continue, 16 take away 15 is going to give you 1, m squared is now 1, m is 1. So now we know what m is, we can replace it. 4 minus 1, 4 plus 1, solution 3 and 5, done. That's a problem solved. Now I did take a while to work through that, but that's because I was taking you through the steps. Alright, let's look at this one then. X squared plus 6x minus 187. Now this is where students tend to get a little bit lost because this number gets so big, the minus sign, all that, they start thinking what to do. So let's go through the same steps. Now here I'm going to use minus 6 because this is a plus 6. We always use the minus orientation of the number. But here's where it comes in. Minus 3 minus m and minus 3 plus m still will add up to minus 6. Doesn't matter what m is. Doesn't matter. Even if we add them algebraically, we'll always get minus 6. So we carry on. We know that if we multiply these two numbers and they equal to minus 187, then we can know what m is. We know that this relationship allows us to find m, a specific m that works for this problem, which is what we're after. So expanding, difference of 2 squared, 9 minus m squared is equal to 1 minus 187. We simplify, we're going to get 9 minus 187, which gives us 196, and we end up with m is 14. Working through, new solutions are minus 3 minus the 14 and minus 3 plus the 14. And so we end up with the solutions minus 17 and 11. Now, people might say, so here when you did the square root, what happened to the minus 14? Now, it doesn't matter if we use m to be 14 or minus 14. I'll show you. So if m turns out to be, if we use m to be minus 14, we'd get minus 3 minus minus 14, which would be minus 3 plus 14, which would still be 11. Minus 3 plus minus 14 is minus 17. Now, if this was a difficult problem for you and you were asked to factorize, but it was a little bit challenging, you could still put this back together in the bracket in this way. X plus 17, x minus 11, even if you were struggling to factorize. So this is like a method in which you could factorize as well and not solve an equation. But this takes us straight to the roots of the equation in a very simple format. 5 simple steps and you get there. So I'm going to stop here with this. This is how it works for this kind of problem. If you're really interested in seeing how we can apply this to more challenging problems where, for example, the answer is an imaginary number or the answer is not an integer, then, or even where a is bigger than 1, then you need to check on some of the videos I'm going to put. It's going to be one of the next videos in the series. So thank you for watching this, and I hope that helps you to solve your quadratic equations. Feel free to let me know what you think. All right, bye-bye.